Welcome all physics tutorial class follower. My name is Waktula. In this video, we'll be discussing on grade 12 physics entrance exam practice part 9. This program is essential for students who will take grade 12 entrance exam, especially on recent Ethiopian new curriculum. To get all weekly published video by this program, please like, subscribe, and share this channel. Our title, Grade 12 Physics Entrance Exam Practice Part 9. Instruction: choose the correct answer from the given alternatives. First, we see the question. Next, explaining each alternatives one by one. Finally, we go to the conclusion. Let me start from question 1. Question number 1 says that according to the equations of continuity, when water fails, its speed increases while its cross-sectional area blank space. Choice A, increase. Choice B, decrease. Choice C, remains the same. Choice D, different. When we come to the solutions of this question, first we have to interpret the given alternatives one by one. The equations of continuity is the fundamental principles in fluid dynamics. It states that the mass flow rate of an incompressible fluid remain constant along a streamline. In other words, the product of the fluid's velocity and its cross-sectional area remain constant. Let us break down the situation below. Once wait me. First, water fail. When water fails, it gains gravitational potential energy, which is then converted into kinetic energy as it is accelerated. This acceleration leads to an increase in velocity. Second, cross-sectional area. The cross-sectional area of the water stream remains the same as long as there is no external factors affecting, such as obstacles or change in the shapes of the stream. If the water is flowing freely without any interference, the cross-sectional area remains constant. As water fails, velocity increases while the cross-sectional area remains unchanged. This relationship ensures that the mass flow rate from this one. Therefore, the correct answer is what? A. A says that increase. The next question. Question number 2. According to the law of electromagnetic induction, which statement is not true? Choice A. A constant magnetic flux across the surface of a circuit induces an electromotive force in the circuit. Choice B. An electromotive force is induced in a circuit when a constant magnetic field across its surface. Choice C. The magnitude of electromotive force induced in a circuit is directly proportional to the rate of change in magnetic flux across the surface bounded by the circuit. Choice D. A changing magnetic field parallel to the plane of a circuit induces an electron motive force in it. When we come to the solution for this one, let us break down the statement. Is when we come to A said that A, according to this one, the idea of A is true. A constant magnetic flux crossing the surface of a certain includes an electromotive force in a circuit. This is described by the Faraday's law of electromagnetic induction. When we come to choice B is false, means an electromotive force is induced in a circuit when there is a changing magnetic flux across its surfaces, not a constant magnetic field. Choice C is also true. The magnitude of electromotive force induced in a circuit is directly proportional to the rate of change in the magnetic flux crossing any surface bounded by the circuit. When we come to the mathematical interpretations of this one, choice C, electromotive force is equals to electromotive force is equals to partial derivative of what phi, the magnetic field, over partial derivative of time, which is where from the given this one, phi is represent the magnetic flux and t is represent the time, and when we come to choice D, the idea of D is also true. Choice D is also true. A changing magnetic field parallel to the plane of a circuit induces an electromotive forces in it. This constant with Lenz's law, which states that the induced electromotive force opposes the change in the magnetic flux. From the given this one, according to this one, the equation, the electromotive force, which is equals to minus of the partial derivative of phi, or magnetic field, over time. So the correct answer is what? B. B says that according to this one, B, when we come to choice B, says that an electromotive force is induced in a circuit when a constant magnetic field across its surface. This is not. When we come to the next question, question number 3 says that two particles, two projectiles are fired from ground level at equal speed but different angles. One is fired at an angle of degree and the other at other degree. The projectile to hit the ground first will be the one fired at degree, neglecting a resistance, choice A, 60 degree from the given this one. Choice A says that 60 degree, choice B 30 degree, choice C both hit at the same time, choice D cannot be determined from the given information. When we come to the idea of what the time of light for two projectiles fired at the same level, let we come to auto interpreting the idea. Let us analyze the situation of two projectiles fired at different angles, while considering the effects of gravity and the initial speed. Projectile motion basics. Projectile motion is refers to the motions of an object. The projectile that is thrown or projected into air, subjecting only the accelerations due to the gravity. The path followed by the projectile is called its trajectory. In this case, we have two projectiles, both starting from the ground level. The first one, when you come to the key observations of this one, both projectiles have the same initial speed, means magnitude of velocity. One is fired at an angle of what? Theta 1. The other is fired at angle theta 2. The time of flight of for each projectile is the total times it takes for the projectile to hit the ground. From this one, the time of flight depends on the initial velocity and the angle of projection. Horizontal and the vertical motion. Along the horizontal axis, means x-axis, the velocity remains constant because there is no horizontal acceleration, neglecting a resistance. Along the vertical axis, the projectile experiences uniform acceleration due to gravity acting downwards. Downward from this one. Comparisons. Let us compare the two projectiles. Projectile fired at projectile 1 fired at angle theta 1. It has an initial velocity v and the same the angle of projection theta 1. Projectile 2 fired at angle theta 2. It also the same initial velocity v, but different angle of projection from the first one. The time of flight is given by the general equation. The time of flight for the projectile can be calculated using the following this equation, which means time of flight is equals to 2v initial velocity times sine theta over g. According to the given this one, we have the same value of for both. Means V initial is the same, G is also the same. We discussing under the same condition, under the same condition. So when you compare this one, since both projectiles have the same initial speed, the only difference in it is what the projection. Since the functions is positive for angles between 0 degree to 90 degree. Therefore, the projectile with a smaller angle of projection will have a larger sine value, resulting the longer the time flight. Conclusions of this one: the projectile fired at the smaller angle theta 2 will take a shorter time to hit the ground. Hence, the projectile fired at the large angle decrease will hit the ground. When we come to the hint of this idea, the time taken depends on the above equation from the given this one. This is what our equation. The time of flight is equals to 2 times initial velocity times sine theta over g. According to this one, changing the value of this theta, sine of this theta as a given value, the product of this one divided to gravitational field strength, approximately let we use 9.8 meter per second square. So we will get what different values. So the largest one hit the first. When we come to the conclusions of this one, from the given this one, the answer is what? The projectile fired at a large angle decreases degree will hit ground last. The first, the smallest one, then the second one. Question. The next question: the rotational angle of mass is moment of inertia, B torque, C angular momentum, D angular acceleration. When we come to the solutions of this one, let we define the meaning of the idea of this question. This statement: the rotational analogy of the mass is the moment of inertia. It is represents an object's resistance to change in its rotational motion, just as mass measures in an object's resistance to linear acceleration. Momentum of inertia measures an object's resistance to angular acceleration. It depends on the distributions of masses around its axis of rotation and is given by the integral of the mass distribution with respect to the square of the distance from its axis of rotation. When we come to the general equation used to calculate this one, I, when I stands for what? Moment of inertia, is the integral of what? R square dm, where d is moment of inertia, r is distance from the axis of rotation, and dm is what represent infinitesimal mass elements. The other options are related to the rotational dynamics but are not directly analogous to the masses. For example, when we come to the given option, torque, option B is a rotational equivalent of force causing angular acceleration. Angular momentum, option C, is a conserved quantity in rotational motion given by the product of the momentum, of the inertia, and angular velocity. The angular acceleration, option D, is a rotation, the rate of change in angular velocity. Therefore, the correct answer is D. The correct answer is A, means moment of inertia. The next question: a device for transforming heat energy to mechanical energy is referred to as choice A, transformer; choice B, refrigerator; choice C, generator; choice D, engine. The device that transforms heat energy to mechanical energy is an engine. Engine is commonly used to convert thermal energy or heat into a useful work, such as moving vehicles or generator electricity. Let us explore a few examples of how this conservation occurs. Internal computing engines, internal computing engines found in automobiles, motor bicycle, and the other vehicles are the types of heat engine. They work in by igniting and computing fuels such as what? Gasoline or diesel inside the cylinder. The combusting process generating high pressure gases that expand, pushing a piston, the movement of the position. Piston is in converting. So the correct answer, according to the given this one, the correct answer is D. D says that engine. In general, today we're discussing different questions that uses students on grade 12 entrance exam. If you have any question, suggestion relate to my subject, please write your comment. Thank you for your attention. Thank you.